How's it going, guys? Chris from Terrestrial Imaging here with another video on the DroMight Rudder Locks for the Van's RV-14. So some of you might have already seen our previous video where we were with our Van's RV-14 outside setting up the rudder lock system, installing it, and showing you the forces applied to the back of the rudder. In this video, we're using a decommissioned wing stand that we used for our Van's RV-14 build, and we've reconfigured it to make a mock RV-14 setup where we have rudder pedals and a mock tail. So in this video, we're going to be applying the rudder locks to our fake rudder system, and we're going to be applying force to the back fake tail to show you guys truly how strong these rudder locks are, to show you all of the forces that they can handle. All right, so again, I'm going to show you guys how to install the DroMight Rudder Locks for the Van's RV-14. Keep in mind that this setup is purely a mock setup used for testing. It is not to scale or one-to-one to a real Van's RV-14, but it's purely used for testing purposes and demonstration purposes. So if we'll look down here, I'm going to take the rudder lock just like you saw in our prior video. I'm going to push one end onto the pedal and let one end fall into the lock. I'll then repeat the process on the other side. This time I'm going to be having some resistance from the tension on the pedals. Now that I've heard these snap in and they're locked in place, they're really not going to be going anywhere and they're going to be able to handle a lot of force. So what we're going to do now is go to the back of our configuration here, and I will be simulating all the forces that you'll be seeing on these rudder locks. All right, so as you guys can see, the rudder locks are fully installed, and I'm here at the back of our configuration setup where I will be applying force to these cables that will be pulling both pedals. So if I push this as hard as I can, you'll see those rudder locks expand and contract in order to keep the tension on the configuration. So I'm pushing this pretty hard, and you'll see that as those rudder locks bottom out, I won't be able to push on that pedal anymore. So I'm still trying right now, and I'm actually turning the configuration because I can't apply any more force. And if we do the same on the other direction, we'll see the same experience. So if I keep pushing back and forth, you'll see these rudder locks able to handle all of the force that I'm applying to it, while once I let go, everything springs back into its normal natural locked configuration. To further elaborate on how we're really testing this, right? Imagine this piece of wood was your rudder. As I pull on these handles, it would turn the rudder left and right. So we're really just simulating those forces on that rudder. So I'm going to push this as hard as I possibly can and aggressively as I possibly can, and you'll see each piston on each rudder lock fully bottom out and then fully extend to hold this rudder lock system in place. All right, so to create a mock scenario, imagine you guys have flown into Oshkosh and the storms start rolling in like they do every year. And you want to make sure that your rudder is properly secure so that way it doesn't hit either stop and cause any damage. So what we're going to do is just going to apply as much force as I can over the next couple seconds just to show you guys how these rudder locks can really handle all that excess force. So I'm going to come to our mock rudder end of our configuration, and I'm just going to go crazy with the force trying to bottom out each rudder lock system. All right, and as you guys can see, that was a lot of force. If you guys are experiencing that out in the field, you're probably going to have more problems than just your rudder staying secure. But once done with this testing, you can see that the rudder locks spring right back into their normal resting position, and our rudder remains undamaged. All right, so to conclude with this video, we just wanted to throw one more tip out for those of you using the DroMight Rudder Lock system. I know it says it in the instructions, but sometimes it's just good to see it and talk about it in a video. But if you take a pen and mark about the 50% mark between the head of the lock and the body, we want to make sure that as you put this rudder lock into its fixed position, that it's going to be compressed about 50%. We want both of the locks to be compressed to about 50% to prevent one of them being fully compressed, the other one being fully extended, and risking one of them falling out. So if this rudder lock system is perhaps too short or too long, again, it mentioned this in the instructions, but you can actually remove the nut and bolt at the back end of the rudder lock, and you can twist and expand the inner tube to increase or decrease the length of the rudder lock to make it perfectly fit for your aircraft. As owners of a Vans RV-14 and a builder of a Vans RV-14, we wanted to make sure that we developed a rudder lock system that could truly handle all of that excess force. And I know all of you RV-14 owners and builders out there are looking for the same thing. We've tried multiple different rudder lock systems on the market, and you might have yourselves, and we've determined that a lot of them really weren't fit for our aircraft. So we decided again to build one for ourselves, and we hope that through this video and through our installation video, we demonstrated just how reliable the DroMight Rudder Lock system truly is. So if you guys haven't seen our installation video, I'm going to drop a link below for you guys to check that out. And if you guys are looking for a rudder lock system of your own for your RV-14, there'll be a link below as well. Thanks for watching, guys, and have a great one.